Hello, ladies and gentlemen. Today we're going to be working on functions. We're going to be learning about function notation, and we're going to be able to look at graphs and equations and tables, and by looking at those, see whether or not it is a function. So we're going to start with function notation today. So here we have an equation in function notation. Now, normally we would see this like y is equal to 3x plus 1. The only difference between function notation and our regular equation of the line is y has been replaced with f of x. So basically you can squint a little bit and just pretend that that is a y. And everything else that we do just assumes that that's kind of the y situation. So to find what this equation looks like on a graph, you're simply going to plug in for x and solve for f of x, which is basically plugging in for x and solving for y. So f of x there, our x is our input value. So if I tell you that x is 12, you're going to go ahead and plug in 12 for x on the right-hand side and solve. The right-hand side is the equation itself. So this is 3x plus 1. And when we solve using order of operations, that becomes our output value, or our f of x, also known more commonly as our y. But when we see that f of x, we know that it's going to be a function. So as we're going to go ahead and look at this, it's not f parentheses x, f times x. That's not what that means. So when we see this, we say f of x, f of x. And it doesn't mean to multiply. I know I've been telling you guys for the past 2 weeks, when you see a set of parentheses, it means to multiply. Well, not in this case. So it simply is going to be a place to tell you that this is a function and you're going to put your value of x in there. We're not going to multiply, we're not going to divide both sides by the value, we're simply going to leave it alone throughout the entire equation. So we're going to go ahead and evaluate functions, which is basically picking x's like we did in our class a couple times ago. We're simply going to plug in an x and solve for our f of x or our y, so we can find an ordered pair that would be on this graph. So example 1, we're going to go ahead and solve when x is equal to 4. So we're going to go ahead and simply take 4 and we're going to plug it into both places where we see our x. So when we've done that, it looks like f of 4 is equal to 3 times 4 plus 1. Once again, we're not going to do anything with the f of x on the left-hand side. We're just going to leave it alone and keep dropping it down. We're going to treat it like it's just the plain old y. But we are going to solve on the right using order of operations. So 3 times 4 is 12. 12 plus 1 is 13. Now, this is our answer when it's in function notation. F of 4 is 13. And the great thing about function notation is it gives us not just a y value, but it tells us both x and y, which is our ordered pair. And then we can plot that on our coordinate grid. So our ordered pair in this case is 4, 13. So that's great. We're going to go ahead and try it with another point on this specific line. So for example 2, we're going to solve when x is equal to -2. Same exact situation. We're going to plug in for each of our x's. So we're going to have f of -2 is equal to 3 times -2 plus 1. We leave the left alone. We don't touch it. We don't deal with it. All we do is go ahead and look at the right-hand side and solve the right-hand side with order of operations. So 3 times -2 is -6, and -6 plus 1 is -5. So once again, this is our answer in function notation, and it gives us both our x and our y in one place. So we know this is the ordered pair, -2, -5. We can plot those two on our number line, on our coordinate grid, and then connect those, and we'll have our line, because we know, because it's 3x, that's going to be a line with a y-intercept of 1 and a slope of 3 over 1. Now, you're going to also see these problems in the opposite way, where basically you're given your y, you're given your f of x, and you need to go ahead and solve for x. So in this third example, it tells you when f of x is 16, find x. So all we're going to do is take that original equation, f of x equals 3x plus 1, and we're going to replace f of x with 16, a direct substitution. So that becomes 16 is equal to 3x plus 1. Now we're solving for x. We already know what our y or our f of x is. So we're going to subtract 1 from both sides. and that gives us 15 equals 3x. Finish up by dividing both sides by 3. 15 divided by 3 gives us x is equal to 5. Now, we already knew what our f of x was, and now we know what our x is. So we know that's the ordered pair 5, 16. Okay, so that's basically how we treat it. It's why we use function notation, is because you can see the entire ordered pair all in one spot. Our second part of our lesson today is to go ahead and take a look at a graph or a table and be able to look at it and say, yeah, that's a function, or not a function. So the first one that we're going to do is look at a graph. So by looking at a graph, how can we tell, is it a function? And we always use the VLT, or the vertical line test. Now, a vertical line, of course, is a line that looks like this, and it goes from left to right. And we're going to go ahead and take a look at that. And as we're moving from left to right, it can only touch one point on our graph. If it only touches one point at any time, we know that yes, it is a function. However, if it touches in multiple places, if it touches a vertical line in 2 different spots, then no, it is not a function. So here's our first example. We're going to go ahead and get our vertical line, and we're going to go ahead and move it across and see if there's a spot where it touches more than once. So here we go. Okay, and as we can tell, if the answer is yes, it only touches one point at any time, then we know that yes, it's a function. If the answer is no, there's a place where it touches twice or more, then we know it's not a function. So in this case, yes, we are a function. Okay, here's our second example. We're going to go ahead and run the vertical line test, which means to go from left to right. Left to right, I'm mirrored. So we're going to go ahead and run it across. And is there any point where it touches that vertical line in more than one spot? And here's an example of where it does. So as you can see, there's a spot up here where it's touching that vertical line, and there's also a spot on the bottom. So because it touches at 2 different spots, this one is not a function. It fails the vertical line test, so a circle is not a function. Now we're going to go ahead and take a look at a table of values, and we'll be able to look at that table of values and see whether or not it's a function. So here's our first example. Here we have a set of ordered pairs that we could go ahead and plot and take a look and see if it passes the vertical line test, but we want to just be able to look at the table and see if we can. And we're basically going to do a flow chart to see if it's going to be a function or not. So step number 1 is ask yourself, is there any repeaters in the x column? So I see a 2, 4, 6, 2, -5. I said 2 twice. That's a repeater in the x column. So yes, we do have a repeater. If the answer is no, then you're done. If there's no repeaters, it's a function and you are done. But our answer was yes, we have 2 2s. So we go ahead and ask ourselves the second question, if there are repeaters. And that second question is, look at the repeater numbers. Do they have the same y value? So my first 2 has a y value of 7, and my second 2 has a y value of 7. Now, if the answer is no, they don't go to the same number, then it is, let me erase that so you guys can see. If they don't go to the same number, then it is not a function. So if one of my 2's went to 7 and my other 2 went to -25, then I could say, no, it's not a function. If the answer is yes, they go to the same number like this example. My 2 goes to 7, my other 2 goes to 7, that means it's a single point on the line. It's not touching at 2 different places. Then it is a function. So this table specifically is a function. Let's go ahead and look at a second example. So here I have this table of values. Step number 1, any x repeaters. I see -3, 1, 2, -3, bing, bing, bing. I have a repeater. So I looked for step number 2. Look at the repeater numbers. Do they have our same y? Our first -3 goes to 7. It's up here. Our second -3 goes to 4. It's down here. So that means that it wouldn't pass the vertical line test. That means that they are not a function, because at that point on my vertical line at -3, it has 2 different values of y. So in this case, no, it is not a function. We're going to go ahead and practice this today with our Desmos assignment, and we will come back together and we'll talk more all day long about is it a function and how to solve using function notation.